Hi, welcome. In this video, we're going to talk about sampling error. Sampling error is a concept about a sample mean and the population mean and how close that sample mean gets to the population mean. Well, what we talked about in, earlier in this chapter is that as the sample size gets larger, the sample mean becomes more stable. It has less variability, and it is always centered around the population mean. So that means it has to get closer. So let's go ahead and look at the statement of a problem. I'm going to share my screen. This is a document you should be that should be available. Sampling error. So let's look at this problem. The distribution of weights of a bear from a specific species is right skewed with a mean of 1,000 pounds and a standard deviation of 150 pounds. A sample of size 49 bears is taken. Okay, so actually, guys, that's a setup. I even call it here a setup. So let's go ahead and just take notes on that. We'll identify parameters and summarize the information in the setup. So let's take a minute and look at the formulas from the formula card. Okay, just reproduce them here. For chapter 7, the mean of mu sub x bar, the mean of the distribution of the sample means, is mu from the parent population. And the parent population has a standard deviation of sigma. You take a sample of size n. The standard deviation of x bar, sigma sub x bar, is sigma over the square root of n. So we're going to use this notation and these formulas. So let's go ahead and identify the mu, the sigma, and the sample size. Okay, and I just hold these values. Mu, the distribution is right skewed with a mean. So this is the population mean. Mu is 1,000. Standard deviation of 150 pounds. So sigma is 150. And the sample size of 49. So we use n to denote the sample size of 49. Okay, so let's go ahead and look at two different ways of asking the same question. I'm going to start with one on the left. And what this question is asking is, what is the probability that the sample mean is within 50 pounds of the population mean, which is 1,000 pounds, right? So we want to know, this question is asking, what is the probability that the sample mean is within 50 pounds? Mu minus 50 pounds on the left and mu plus 50 pounds on the right. Okay, that's what this question is asking. All right. And then I just take a moment. I do have this on the whiteboard, and I'm going to work through it at the whiteboard in a moment. I just want to look at another way of asking the same question. The sampling error made in estimating the mean weight of all bear of that species by the mean of a random sample of 49 bears will be at most 50 pounds. What is the probability that the sampling error? So first of all, let's go ahead and define sampling error. Sampling error is the absolute value of x bar minus mu. Okay, so mu is this fixed value in this problem, 1,000 pounds. And so we are looking at the sampling error of x bar minus 1,000 pounds. X bar we know is a random variable. It has a distribution. And because it has a distribution, this transformation, absolute value x bar minus mu, also will have a distribution. And that's what this problem is about. You don't have to do this sort of transformation a lot in this class. I just want to show you how these problems are often stated, particularly as you move forward into your methods courses. Okay, so this is particularly of interest for those of you that will be using this in methods courses for research. So the sampling error is defined as x bar minus mu, and this question is asking, what is the probability that the sampling error will be at most 50 pounds? Okay, so this whole thing is sampling error. You can replace that. Will be at most 50 pounds. And so that's what this is looking for. Okay, let's go on over to the whiteboard and solve this problem. Okay, so this was the probability question on the left column that we were looking at, the probability that mu minus 50 is less than x bar is less than x bar plus 50, or really how we stated it was that x bar was between these values. Okay, and that's something, you know, that we know how to calculate, because this is let's go ahead and substitute in what we mean by mu. And in this case, it was 1,000, right? The population mean was 1,000. So really what this question is asking for, it's asking for the probability that x bar is between 950 pounds and 1,050 pounds. Okay. So this problem now looks like the probability of a bounded region. We know that x bar is going to be normally distributed because the sample size is large. But for right now, let's just get it to this point because we know we can draw this picture. All right, and now let's look at what this statement of the problem is, because you have to be able to read the questions or understand the questions that are of interest and sort of translate them into something that your tools can address. So let's go ahead and say, what does it mean for the absolute value of x minus mu to be less than 50? So what that means, I'm just going to write this over here. It would be that so the absolute value of x minus mu is less than 50, means that x minus mu is between minus 50 and plus 50. And so let's go ahead and substitute in what mu is and just put the probability wrapper here, please. This is a probability question. So let's go ahead and substitute in for the mu of 1,000. Okay. And so we have the probability that we're going to add 1,000 to both sides, minus 50 plus 1,000 is less than x bar is less than 50 plus 1,000. So we're adding 1,000 to isolate the x bar. Okay, so cleaning this up a bit, minus 50 plus 1,000 is 950. Okay, what is the probability? 950 is less than x bar, is less than 1,050. Okay, and at this point, we see now how the two statements are asking the same question. All right, so what I'm going to do, I'm going to lay out the problem and we'll do that probability calculation. I'm going to clean the board. Okay, so we have the problem laid out here. These were our population parameters, sample size, and what we're trying to get at. We know that the shape of the distribution of the sample mean, we need to comment on that. Well, the parent population was right skewed. Okay, but the sample size is large. This is a little snippet from the notes, okay? So, and from the textbook. So what happens as the sample size gets large is that even though the parent distribution was not normal, the distribution of X bar is approximately normal. And so let's go ahead and draw that up on the board. We have X bar. That is approximately normal. And we know mu sub X bar equal to mu, and that's 1,000. And sigma sub X bar is equal to sigma over the square root of n. And now we have to substitute in here. I'm sorry, I believe I had an error on the whiteboard, excuse me. N is 49. Okay, I'm sorry as well. Sigma is 150. Okay, so substituting in the sigma sub X bar is sigma 150 divided by the square root of 49, 150 divided by 7. Let's get that to 2 decimal places, one more than is given in the problem statement. And that's 21.43. Okay, and so that is the distribution of sample mean. And we are looking for in the problem statement that we are between, that X bar is between 950 and 10 and 1,050. So here we are. And let's go ahead and take a guess. Doesn't matter if you kind of draw these in the wrong place. The real point is just to get a picture. We're looking for the area in the middle, and we want the lower bound to be 950 and the upper bound to be 1050. Okay, so this is normal, approximately normal. And we'll go ahead and transform. Okay, so we're going to use the formulas on the notes and also on the document with the problem. So the question is, we have to find these delimiting values. And then we'll go ahead and be able to calculate that in the on the Z graph. So Z of 950 is equal to X bar. So Z is, here's the formula, X bar minus mu divided by sigma over the square root of n. Okay, and in this case, the X bar is 950 minus 1,000 divided by sigma over the square root of n. We already calculated it here, so we'll take that whole thing, 21.43. Be careful not to divide by n twice. Or square root of n, okay? And let's express this to 2 decimal places. Take out your calculators, please, and work along with me. I'm getting 2.33. Okay. And negative, excuse me, right? Rather. And now, so this is our little box that we usually get on the bus with, and the z of 1,050 is going to be 1,050 minus 1,000 over 21.43, or plus 50 over 21.43, and that gives us 2.33. Not a coincidence. This is a symmetric problem. The delimiting z-scores are going to be opposites of each other. Okay. All right, let's take it from here. I'm going to pause. You guys pause, go to the formula cards. Let's look up. So we have to find the area of the bounded region. So we're going to go do 2 lookups and a subtraction. Okay, so 2 direct lookups and a subtraction, and I get that the bounded region between minus 2.33 and 2.33, 0.9802, and we get the same thing here, 0.9802. Okay, and that's what I wanted to say about standard error. So standard error is really just another way of asking the question, how close to mu is X bar right now? Okay, is it within 50 of the mean? That's what standard error is.